All right, I got the recording going. Happy Wednesday. Hopefully that fan wasn't too loud. I don't know if anyone actually watched the recording from Monday, but a bunch of people did, and no one said it was terrible. No comments on it. So hopefully the sound worked out okay. So first thing, the Blue Carpet Welcome Day. Super exciting event. I've never heard of it before, but that's okay. They're trying new things to welcome students in and make you feel welcome on campus, because it can be rough sometimes. So if you're an incoming freshman or a transfer student, you're invited. Even if you're not, just register anyway. It's a free lunch. So they've got information about the college and departments in the College of Engineering and Computer Science. Faculty and staff will be there. Interactive and fun lab visits. Sure, sounds fun. Hands-on activities. The student competition teams is super cool. There's a couple different ones that I know of, and there's probably more that I don't know of. My favorite one, just because I think it's super interesting, is there's a annual competition on college teams that build autonomous snowplows. And they go out to Minnesota in the winter and they test them in a parking lot, which is interesting because like self-driving cars is cool and all, but with snow, it has to go somewhere. So like you add this complexity into how do you make this thing drive itself and not run into anything and put the snow somewhere in a way that makes sense and can plow a location. Like if we could have autonomous snowplows, we would save so much money. I help do the bills at my church, and we pay like $8,000 a year for people to plow our parking lots, and I just cry every time I have to write checks for that. Like that's so much money to pay just to make someone plow the parking lot. So if we could have our self-driving one, I'd be super happy. But it's not quite there yet, technology-wise, but we're getting there. So I find that one super fascinating. And who doesn't want to go out to Minnesota in the middle of winter? You guys don't look excited. That's okay. That's all right. Another competition team I know of is the rocket team. Personally, I'm a little scared of rockets because I don't trust myself to do things right and not go boom. But they've got, or at least the person who used to coach the team was an actual NASA engineer. So I'm sure they did all the things the right way and would not go boom. I don't know who's coaching it now. I think she retired, but they've got good, really smart people who know how to handle these things safely. Like if I tell the computer to do the wrong thing and it goes beep boop bop instead of beep beep beep, no one really cares, right? So I just stay away from rockets. I think they're cool though, so that's a fun one. I think there's a robotics club that does other cool things. There's like an actual vehicle one if you like race cars, that sort of thing. Sure, so go check it out. All the teams will be there, and lunch, right? I think you do need to register though, so I posted this link in Canvas. If you go to Canvas and check out the announcements, it's the Blue Carpet Day announcement. Very exciting. You probably got an email unless you've turned those off. You'll get used to Canvas sending you lots and 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 lots of emails. Some of them are good. A lot of them you don't care about. So like every time I put a file in there, it emails people, which is a little annoying if I'm like trying to load a bunch of like lecture slides and other things like that. So good news is I don't have lecture slides, so you're not going to get notifications for that. I just do the recordings, but we'll see that sort of stuff in Canvas. So, all right, I did get the Canvas site up. Forgot to mention that. I probably should have started with that. So here's the Canvas site. Yay. Our syllabus is out there. A link to my personal website is out there just for fun. It's got all my GitHub repositories and courses that I've taught. It's in a little like one paragraph bio about me if you're curious, and some links to my other pages. And then my Discord server. This one I think is a great resource. I love Discord, and I think this is a nice way to ask questions and where everyone can see the question and see the answer. And sometimes you answer other people's questions for me, and I love it even more because I didn't have to answer the question. Bonus. But that way, like, I don't get 10 emails from someone. Like, I get a question in Discord and an answer, and then a bunch of people see the answer, and I don't have to get 10 emails. So email's okay though too, but that's a great place to go hang out there. And I'm working on trying to build it into more of a network. If I can get people to not leave the server right away, eventually when people go out and get jobs, they can tell us who's a good place to work for, who's not a good place to work for, or when they're like a senior level, hey, who's hiring? That sort of thing. So I do have one former student who was hiring a software intern. I was able to share that. I was really excited for her. She moved up relatively quick into her role, which is cool. She was really smart. But that sort of thing. So, and it's a great place to post memes because we all love memes, right? Somehow, it's not just my generation because I'm a millennial, but I hear you folks like to communicate with memes as well, because if you don't have any humor in your life, it's just kind of crushing the daily realities. So we can take the edge off with a little bit of humor there, I suppose. Is that fair to say? Cool. And then I'll post the course repository as well. I'll show you what all that means in just a little bit too as we get going. So let me take a look. I think we're going to wrap up chapter 1 today. I got to go double check the schedule because I can never remember here. Yeah, chapter 1. So we're not going to get super far. We'll actually probably be able to get started on chapter 2 because chapter 2 is bigger than chapter 1, and we don't have all of next week because of Labor Day. So no lab next week, no meeting next week. If you come to class here, you'll be lonely. There's probably stuff happening on campus. I don't actually know that for sure. I mean, we can go check out the website and see if there's stuff happening. But welcome back event. Oh no, that's like 2 weeks from now. So I don't know. There might not be anything happening on campus either. So enjoy your Labor Day. All right. So we talked real briefly about Python, real briefly about GitHub, real briefly about PyCharm. So we'll spend some more time today talking about those things. I don't know if you had a chance to check out the Zybooks yet. I want this one. There we go. So Zybooks is really cool. It's our textbook, your textbook, and you get points for reading it or doing it, essentially. Like it's interactive. I think I warned you, these labs here are going to be tedious is probably the most correct word for them because they're very particular about your spaces. And when attention to detail is a good habit to get into. I will warn you, though, they take time. So, and did I mention the score that you get for Xylabs, I'm not going to look at every week because that's a lot of work for me that I don't care to do. So you should be doing it every week when we cover that topic. If you don't, I'm not going to bother looking. You'll just get behind. And then when you do finally get time to catch up, you've got lots of stuff to do, and you're going to be upset at me, you're going to be upset at the class, you're going to be upset at Zybooks, and you're going to have a bad time. So do your best just for yourself and try and keep up to date. If you don't, no big deal. Like you can manage your own schedule. I know some weeks are busier than others, and that's fine. So work it as you need to, but don't leave it for the last day or the last week, right? I had someone do that one semester. They left it all till finals week. I was going to end it, when class ended, not finals week. They're like, oh, I didn't finish it yet. Can you go into final, like when we take the final exam? I was like, oh, sure, that's fine. I went and looked, and he had done none of it. It's like, buddy, you're in for a bad time. He's like, I know. And he got it, like 90% of it done. And he's like, that sucked. Like, yeah, it did. But it's self-inflicted. So the Xylabs are great, and they'll take you through, here's the different steps. Now, I haven't turned them all on yet. So they're like, they give me a library of them, and I have to go turn them on. So they're not on yet for chapter 2. I'll make sure I do that soon. So you can't really like work ahead in the Xylabs yet. I'll try and get a little bit ahead here. But I don't know, do you want all the 15 weeks turned on like tomorrow? Or is it okay if I turn them on week by week by week?
I think that's fine.
Okay, all right. Yeah, I've never often had people be like, I really want to get ahead on these. Some people are very excited, but that's fine.
We'll just do silent until nickname and
For Zybooks, you can make an account. I think you need to use your UMich email. I think you're supposed to. I don't know if it cares if you don't, because if you give them money, they're going to give you the book. If you use your UMich email, I don't know, like it links it somehow. But it's a separate fee, unfortunately. So you have to pay for it. Yeah. It used to be cheaper, and then Wiley bought them, and they're one of the big textbook publishers. And they're like, we can jack up our prices because we're a textbook publisher now. So thanks. Yeah, it's not Pearson, so it's slightly happy. Like Pearson would be twice as much because Pearson's just awful. But Pearson is suing Chegg, so that makes me happy. But okay. All right. So what I have is a GitHub repository for the class. This is just a very fancy term for a folder. So a repository is a folder that the Git source control tool is watching for changes in. So right now, this is the website for it. So anyone can go out to the website. It's public because it just makes it easy. I don't have to give access to you folks. And I don't really care if it's public because it's just class examples. Like there's nothing interesting here. Now, your like proprietary work stuff that you do is probably not in the public repository because it's proprietary work things. So, and that's how GitHub makes their money. They sell this service to companies to let them have private repositories. If you want an open repository, they're like, sure, heck, go for it. You can make some open source code. Yeah, have fun with it. So what I'm going to do is I'm going to make a copy of it. So the technical term for that is a clone. So I'm going to click this green code button, and I'll say open with GitHub Desktop. I've already installed it, so it'll work. If not, you can go install it. Now what it's going to do, it's going to say, hey, I want to take this repository that's out in the cloud, and I'm going to make a copy of it and put it here. This is in my Documents GitHub folder. This is the default location. Sometimes on your computers, if it's a Windows computer, it's really excited to use OneDrive, and it will put it in your OneDrive Documents folder, which is kind of funny because Microsoft owns GitHub, so now they will have 2 copies of your code in their cloud, one in the GitHub cloud and one in the OneDrive cloud, which is a little silly. It doesn't have to be there, but sure, it doesn't really matter one way or the other. So just know where it was put, because it will be important when we do our projects. So I'm going to hit clone here. It'll make a copy of it for me. Just takes a second or two. And I've got 2 buttons that are super important now. I have a Show an Explorer button. So if I don't remember where this folder is, I can say Show an Explorer, and it will open up my File Explorer to this location. And I can click in this white space and it says, hey, C users, CHR1, documents, GitHub, yada, yada, yada. Long name here. So if I don't remember, that's where it is. Okay. If I want view on GitHub, it'll launch the website back out, so I don't have to type the URL back in, and I can see what's online. So as you work through your code and your projects and your assignments, you'll be using a GitHub repository that is private, that you have access to and I have access to, which is perfect, because you don't want other students to have access to your code, because if they turn in the same thing that you turned in, it looks like you cheated, and you don't want that. Right? It's bad for all of us. We have to do a bunch of paperwork and have meetings, and it's awful. I hate it. Okay, it's a big waste of time. So we'll use private repositories. There's a classroom GitHub tool that does that for us through a website, which is fantastic. We only use some of their features. They do a lot of bells and whistles. It's okay. So we'll do this again for our first lab, and I'll show you again next week when we start the first project, because everything will happen in GitHub repositories, because code should not go in Canvas. That's a hill I'll die on. Right? Canvas is not meant for code files. It's not. Let's use a tool that's meant for code files, that is actually used in the industry to deal with our code files, and we'll all be happier. Okay, so this is the class repository. So all the things I do in class will show up here on this website, and I can actually link this in Canvas, which is nice. Let me go add that here before I forget. This is our course repository. Look at that, I typed that word before. Who knew? So that link will be in Canvas. You can just click that if you ever forget. You don't have to memorize it. Eric Chernesky is a long word to spell. Chernesky has 9 letters in it. It's okay. My poor kids, we gave them the hyphenated name, so they have 15 characters in their last name for all my kids. So they match my wife's last name. It's a lot of letters to type. And I set them up with email addresses, and it's their name, first name, last name @gmail.com. And the poor kids have to type this all the time or write it on forms all the time, and I just feel bad now. So it's a lot of typing. So links are good. Right. Oh, we don't need Visual Studio. Sorry, that was from last class. All right, so we got the course repository. So now what I'm going to do in PyCharm, when I start a project, I'm going to put it in that folder, because that's the repository. Right? This is my 1500 or 1501 repository. Or PyCharm wants to open the last thing you did. I don't really care about that. I'm going to go close this. This was our little Hello World program. So I'm going to say File, New Project. Or you could close it and go through the other new menu as well, whichever you like. So New Project. Now this is the important piece. It says, where do you want this project? I don't want it in this PyCharm project folder. If it's here, GitHub won't be able to see it. Right? That's sad. I want GitHub to be able to see it because I want to be able to get it out into the cloud. So I'm going to change this. Now their file browser is stupid and I don't like this one. You can go do it yourself. You can go find your documents folder and expand out and find GitHub and go find 1501 fall. Okay, I'll go find the folder. Now, when you do your projects and your labs, you'll have one repository for each of them because it's a nice way to keep them contained and organized and things like that. I'm not going to do a different repository for every week of class. So I'm going to put another folder in here. You guys can just make your project right in that repository because that's the only thing that's going to go in there. I'm going to make folders to organize the stuff in one big repository so that you only have one link to go follow if you want to see all the class examples. So just a slight difference. I'll use one repository. You guys will have like 15 by the time we're done with all of our labs and all of our projects and the final project. So just a bunch of folders. I'm just going to use one because it makes life easy. So let's call this Chapter 1. This is my Chapter 1 project. Again, the virtual environment thing, usually nice to do a new one. If it's too slow for you, it doesn't really matter too much one way or the other. Not until like the very last week do we actually start dealing with any of those packages that would matter. But it's the way Python gets installed, it's considered bad form to add stuff to the Python install for your computer. You want a copy of Python that you can add stuff to so you don't muck up the other things. Because you can do some weird stuff in Python with packages, so that's fine. And then we like this checkbox for create a main py welcome script because it makes the file for me. If you don't check that box, that's okay. You can make your own file. It just takes another step here. So if you check a box, you have one less thing to do. And I'll say create. And now it says, do you want it in this window or a new window? If you say this window, it will close the current project and open the new project. If you say new window, both projects are open. Just depends on what you want to do, right? I like this window because I don't care about what was open before. If you get this little pop-up, it's okay. So because Git is such a widely used tool, PyCharm knows how to use Git all by itself. It can do all sorts of Git things. I don't usually use each development environment's Git integration or Git tools because then I have to do a bunch of different things. And when I teach students, they all see a bunch of different things. When I teach all the different languages I teach, GitHub desktop client is the same for everything. And that makes me happy because it's one thing that's the same no matter what language I'm using. Both will work. So if you want to click the button, download and install, it will work. And sure, there's not wrong to do it that way. I prefer the GitHub desktop clients because it's the same and it makes my life easy. So I'm just going to ignore that. It'll pop up a lot. And then I don't actually care what's here for my code. I didn't figure out the zoom thing. Shoot. Let me go to my options here. I want to zoom, because that text needs to be bigger here. Editor, font, increase, no. It'll work on Mac OS. I don't know if it works on iPad, because I think it's a different operating system than the MacBooks, but I know very little about Macs, because I just don't care about Macs. Sorry, so I'm not exactly sure. Is it Zoom IDE? Is that it? No, shortcut. Sure, let's try that. Nope, that was not what I wanted. Shoot. Come on. I reinstalled this to the latest version, and now I lost my Zoom in IDE? Zoom? Isn't it? Like editor? Ah, change font size. There we go. That's the one I wanted. Oh, okay. Now I have to get rid of that other shortcut. Sorry. So you guys probably won't zoom very often. You might just set it once. I zoom a lot because that helps me get it for you guys. So we want to clear. There we go. Okay. There. So now I can zoom my font. So it's a little easier for you folks to see up on the screen and in the recording. There. Sorry, you probably won't have to do that. So again, I'm just going to delete all this because I don't really care about it right now. But it's nice that I have a main py file, right? I've got it here. And then we can add in print and then in quotes, hello world, like we wanted. This is our first example. And then you can right click run, you can hit the run button, you can go to the menu, go to the run section and hit run. Right? 3 ways to do everything. Whatever shortcut you like, go for it. And we should get hello world, right? I think I can, yes, I can zoom this one now too. Nice. So I can zoom my output. Life is good. So my project works, it runs. This is a nice little starting point to know that life will be okay. Now in the GitHub desktop, now it says, hey, there's a bunch of stuff in here. This is good. This is Git doing its job. What the Git source control tool does is it watches the folder that is a repository and says, hey, something changed. So all the things that are green are new files. It says this file's new, this file's new. So anything in this .idea folder, that's there because it's a PyCharm project. Just let them be there. If it changes, it changes, whatever. Like just, you don't have to touch them. Just they're there. What we care about is the Python file, the main.py file. So I can see, hey, there's one line in here, hello world, print hello world. Great. What Git does and how it works is it does these snapshots or commits. So commit's the term for it. It's a snapshot of what's in the folder at that point in time when I click the button. That's what it's going to track for me. So I can give it, or I have to give it a commit summary. So the summary is required. The description is optional. Depending on your organization, they'll have standards around what goes in what box. Just smile and nod. It's not hard. I don't care what you put here. Some people like to be funny. Some people like to swear at their computer. Some people just put A. I could care less. What I would say is good is something meaningful. Like, what am I doing here? What is this commit here? This is, like chapter 1 started. Now, this will show up later, is why I think it's useful to be meaningful, but no one really cares. Like, for our purposes, it doesn't matter. Now that I committed, I've taken that snapshot. It says nothing's changed. But the cloud doesn't have my change. So this button lights up here and says, hey, you should push. So when I push my changes out to the cloud, it will synchronize my copy of the repository with the cloud copy of the repository. So the technical term Git is a distributed source control system. So anybody who has a copy or a clone of the repository has everything. So what we do is we push to the cloud, the central repository, and we pull from the central repository. So if it's just me working, I'm only ever going to push and push and push and push. If I'm working with other people or from multiple devices, I need to push and pull to make sure that when I start on this device, I'm in sync with the latest version that the cloud has. So I'm going to go ahead and push. Then what I can do is I can view on GitHub again, because I forget the URL or I don't like to type things or I don't want to go find the link. And now it says, hey, there's a folder called Chapter 1. I can click that, and I can explore, just like File Explorer lets me do, and I can find the main PY file, and I can click that, and I see the text here. Now, it's not very interesting. There's just one line of code, print hello world. But I can see my code made it to the cloud. Once your code's out in the cloud, it's really, really, really hard to lose it, because GitHub makes their money selling the service to organizations, and it's really hard to get clients if you lose their stuff. Right? That's pretty bad, right? If you sell this as a service and then you lose their data, they're going to be upset with you, right? So sure. So this is great. Now I can see my code here. Now what's going to happen is Git is actually very smart at tracking changes, and it will track them at the line level. So in here I could say print Happy Wednesday. Again, full quotes or apostrophes, either one's fine as long as they match. And we'll get into more of that later. So Happy Wednesday, and then print yay internet. I'll give it a run, make sure it works. Now notice I've got extra lines here, but they don't show up here. Right? The lines in your code are just there for us, because it's just a visual separation of what's here. If the line's empty, Python ignores it. It could care less. You can have 50 lines of difference here, you can have one line of difference here. Python doesn't care, right? It will do the exact same thing. So generally we use this white space or the separation here just to organize things for us and group things together. The actual code here that we write really is for people. It's for you to read, for me to read, and for our teammates to read, and for anyone else on the internet, if we publish stuff, to read. It just happens to follow the rules of Python and follows the Python syntax, so Python can also read it and do what we tell it to do, right? The code's for people. So now if I save my changes or run it here, and I come back to the GitHub client, it shows up in orange. It's like, hey, this file's changed. If you're colorblind, it's just a dot. You get a plus for new, you get a dot for change, you get a minus for delete, or green, orange, and red. And you'll see, because it tracks things at the line level, it says, hey, your old line 1 on the left is gone. You have a new line 1 on the right. Now this looks a little confusing because it looks identical, but it's got this really tiny icon here that says there is no new line, no return at the end of this line. The new line 1 has a new line character that says go down a line in your text file. Very minor difference, we don't really care, but it's slightly different. So it says this one's gone, this is new. And we'll just say, hey, this is Happy Wednesday or something. Again, just make a commit and push. And I think I still have the browser open. I'm just gonna wait like half a second and refresh here, F5 to refresh, and now I see the latest version. So if you can see your code on GitHub, if you can see your code on github.com, I can see your code on github.com. If you can't see your code on github.com, I can't see your code on github.com. I think that makes sense, right? So what you're going to do to turn things in is you'll come out here, find your file, grab this URL. It says, hey, here's a repository, here's blob, don't worry about that, main, don't worry about that, but chapter 1, main PY, here's your PY file. You'll just grab this URL and give it to me and turn it into Canvas. Canvas has a box for URL to turn it, which is awesome. The other cool thing you can do is if you're having problems with your code, you can come in here and you can say, hey, line 3, and click on it. Now the URL says, hey, go to line 3. If you send this to me in a message or on Discord or in an email, say, hey, Eric, I'm having trouble at this line, I'm getting an error, and you tell me what the error is, I can go look at your code on github.com, and at this point, probably 95% of the time, I know what's wrong without even opening PyCharm. I can just look at the code on GitHub and be like, hey, here's your problem. I've done it a lot. That's okay. You'll get there, right? Take some practice. Don't sweat it if you don't right now. Every now and then I'll just copy your repository and open it up in PyCharm and actually run through it and see what's going wrong. But most of the time I just need to look at it. So that's the beauty of this tool as a code collaboration tool, that it puts it out visible on the internet so people can look at it and read it and see it without having to download it and run it. That's great. We love it. It's fantastic. So we can do stuff like that. So the general rule of thumb, and I always tell people you should commit early and often. Commits are free. Well, so free is technically wrong. There's no charge for a commit. Technically it uses some electricity because it does stuff on your computer and puts that stuff out in the cloud, and the cloud has to do stuff. So it costs money somewhere, but we don't pay for it, so we don't care, right? you should be looking at me like that I'm an awful person for saying that. It's not as much electricity as Bitcoin uses, so we can be happy about that, right? We can yell at Bitcoin wasting resources and be like, GitHub, it's small, it doesn't matter. And that's probably true. So anyway, Microsoft runs it, and they're trying to get carbon neutral anyways, which is pretty cool. So like, they're paying for it. So really, you're paying for it when you buy Windows and Microsoft Office and other things that Microsoft sells. But sure, so somebody's paying. All right, long story, I'm sorry, that's the wrong tangent. So we can get our code out to GitHub. So the first lab we would have done is doing this, making a copy of the repository, making your project, printing a little hello world. It's going to be an introduction. It'll answer a couple questions about yourself. It's get to it a week from Monday, because right, we're not meeting Monday for Labor Day. Don't come, you'll be lonely. We'll do that, and then we'll do the actual lab. Or maybe we can even just skip that one, because it's like one extra step. Not too big of a deal. I'm talking really fast. I'm like halfway through my pot of coffee already, which is actually a little behind for one, but that's okay. All right, questions, thoughts, concerns? We okay so far? Someone had asked me about comments. So if you want to add notes to your code, or we call them comments here, you can't just type stuff here, because Python gets upset. And you get this big ugly red line that says unresolved reference. Garbage. What you can do is you can put a pound sign in here. Again, not a hashtag, it's pound sign. Eventually, we'll start calling it a hashtag everywhere, but the majority of developers are older, and we're all cranky old people, and don't call it a hashtag because it's called a pound sign. Really, it's called an octothorpe, but no one calls it that. It's called a pound sign. I'm sorry? Octothorpe is the technical term for it. Most everyone I know calls it the pound sign. Everyone else, young people, call it a hashtag. Sure. Whatever you want. So technically, I think that's wrong, because the hashtag is like that and the message, like some tag here. Like this is a hashtag, right? The sign itself, the hash sign or the pound sign or the octothorpe, is not a hashtag. Like it's not a tag unless you give it text. So, and we can be pedantic and argue about things because this is academia, and it's fun to pretend you're smarter than people. I'll try and tone that down. I'm sorry. That's the bad part of me coming out. Okay. But I can leave comments here. Right? And I can, if it's followed by after the pound sign here, Python ignores it. And notice it shows up kind of gray. That's PyCharm's way of telling us, hey, visually, this is the comment that's going to get ignored here. Comments are ignored by Python. So if you can put comments in, if you want, that explain part of code. Now, depending on where you work, different organizations have different standards. Right? I think we acknowledge everyone's a little different here. And whoever writes your paycheck, when they tell you to do something, you just kind of smile and nod and say, sure, I'll add comments if you want. A lot of developers in the industry have gotten away from doing comments for lots of reasons. And I'll demonstrate one. So this one, this line of code prints, yay, internet, to the screen. So I can leave a comment that tells you what's happening here. Sure, and this is a bad example because print is a very easy thing to do here, but you can get some very complex things that happen in your code. Sure. But this comment now matches this line of code, right? But what I can do in here, I can come in here and change this and say print, my name is Eric. The comment didn't change, even though the code changed. This is why most developers think comments are awful. Because now I have to do twice as much work because I changed the code, and now I also have to change the comment. And sometimes we forget to change the comment, and the comment has nothing to do with the code because the code has changed. And then 3 years later, when someone's looking at this code, they have no idea what happened, and no one has touched it since then, and we get very confused. So again, we tend to frown on comments, but they're very useful for certain purposes. They're great for lots of things. I try not to use them because that's just my habit, my condition there. But always happy to add them if it's useful for you. And a nice place to take notes sometimes. Okay, so we'll just do that. This is wrong now. Oops. Or ope. Ope is the Michigan word here, right? You'll hear this all the time in the Midwest. Instead of oops, like ope. Oh, okay. I thought it was funny. And I never realized how much I said it until someone pointed it out. Right, now I'll come back to GitHub and I see, hey, more new lines. Right? Now, because it tracks it at the line level, it says, hey, your old line 5 is now line 10. It didn't change, a bunch of stuff got added in the middle, which is really cool. So when your projects and programs get bigger and bigger and bigger, and you've got like thousands of lines of code in a file, it's really nice to just see the 3 or 4 or 5 lines that changed, not, hey, this entire file changed, and have to track what changed when, where. It's really cool. So add bad comments. And I'll commit and push. And then let me show you out on github.com, when I said you can see that commit summary here, you can see what it is back on the page here. Oh, goodness, there it goes. On the GitHub website, you can click this little 4 comments link, 4 commits link. I got comments on the brain, and you'll see all of the code commit summaries that I wrote here. Add bad comments, happy Wednesday, chapter 1 started. The initial commit was when it was initially created, not a very interesting one. And I can go back and see what happened in that commit, and I'll see the changes as we saw them in the GitHub client. Hey, this line was removed, these lines were added. So you can go back to the history of the file and see what changed when in the repository, which is super cool. And then at the file level here, there's an option in the file, where is it here? This blame button is super fun. It's called blame because we get to figure out who to blame when the code doesn't work anymore, because it tells us who changed it last. When you're working in a team, right, you'll see different people's names here. I'll show you an example in a minute here, but you'll see the commit and when that line was changed. So in the commit Happy Wednesday, this line showed up. In the commit add bad comments, these lines showed up. In the commit Happy Wednesday, these lines showed up, and on and on and on. So in a very large file, like GitHub, like Microsoft, we'll go to Microsoft's page here. We'll find, how about the VS Code repository? So this is the Visual Studio Code program is open source. We can go to their source code, and we can go look at some of these things in here. I don't even know. It's all in JavaScript, which is awful, but that's fine. How about in here? About the editor? I don't know. There's a bunch of things in here. Editor, main, sure. Let's try this one. Oh, that's not an interesting one. Goodness. I've never looked at this stuff much before. There we go. So here's some interesting looking code. Bunch of stuff in here. This is 1,300 lines of code or so, right? You can go in here and look at the blame and see what changed when. So if you're running your program and you run into an error and the error says, hey, at line 27, I got this error here, you can go find line 27 and see, oh, TSFMT changed this line 7 years ago. Do you think the problem is really here from 7 years ago, or is it like this thing that changed 4 months ago? And that's, you can go through and you can investigate what changed when. This is one of the features of Git, because Git tracks changes at the line level. So you see the last time that line changed, which is really fun. For our purposes, when it's just you making changes, you've got no one to blame but yourself. Ha ha ha. You guys don't laugh at my bad jokes. It's okay. There's no points for laughing. So it's useful. We're not going to use much of it here, but it's cool to know, I suppose, is the moral of the story there. It's fun to find out. All right. So moving on. Let's see. Back to, let's bring it back now. Where were we here? Errors and we get to errors and warnings. We didn't even get to there yet. We did comments and white space. There we go. We're getting there. We got through one section. We got a couple more to go. So with errors and white space, if you don't end your quotes here, notice now I get a red line, and I try and run Python, and I get a red output here. It says syntax error, unterminated string literal detected at line 10. And then you get a little output up here. So this is known as the stack trace. Don't worry about that. It's a technical term. We'll get to it more later. But it's saying, hey, at this line, somewhere around where this caret is, a bad thing happened in your main file, line 10. An unterminated string literal. I have a string. A string is a fancy term for a bunch of text. And we do that with quotes here. We didn't terminate the string. So I started a quote, I never ended it. Right? That's what this error means. Once you've worked with it enough, the errors will start to make a little bit more sense, and you'll see what they mean, or understand what they mean here. They're not always perfect, but they're usually pretty good. So maybe if I forget my parenthesis and I try and run it. Now we get a syntax error, parenthesis was never closed. Sure, okay, let's put that one in. And maybe if we take this one out, what do we get here? I get unmatched closing parenthesis. They sound a little bit different, but it will try and point you at where the error is. And PyCharm itself will give you red lines, and you just hover over the red line, and it says end of statement expected. That's not super useful. Like, what does that mean, end of statement expected? Because really the problem is we never started the parenthesis here. That's all. So here, let's start the parenthesis. Sure. If you mistype print here, you have prin. you get a red line. It says unresolved reference, prin. Unresolved reference means Python has no idea what you're talking about. It doesn't know what you're referencing here with the prin, right? So it'll point you to that area, and then we try and run. It says the actual error here is much more helpful than what we get in PyCharm. It says, hey, name error, name prin is not defined. Did you mean print? You're like, yes, thank you, Python. So they've added in a couple of these things for some common errors where they give you more better details, or better details or something. Sorry. Sure. So it's nice. And sometimes it gets kind of laggy and slow when you saw like it was red and then it wasn't red and then it stayed red and now it turned. So generally it color codes things for us. So we can see stuff in green is strings. It has quotes. Stuff that's a little bit purpley is like it knows what this thing is here. That's all. So we'll see some of those. So we should be able to run it. And eventually it should run. And it should work pretty well for you. That makes sense so far? So we'll get some errors there. Computers, all sorts of fun things about computers. The language history, Python has been around for a long time. It's not as much of a problem anymore, but a while back, Python had version 2, and they said, we want to go to version 3 for lots of reasons. And everyone's like, oh, version 3 is very exciting, but version 3 was different enough from version 2 that all the stuff in 2 didn't necessarily work in 3. And it took a lot of time for things that worked in 2 to get translated and moved over to work in 3 because people just took their time doing it. Is that a question? Oh my goodness. Yeah, no, I went to the wrong tab. Sorry, thank you. Yeah, thanks. Yeah, I'll just close that tab. Good catch. You get 5 extra bonus points. Unfortunately, they don't actually mean anything though. There's no bonus points in the grade book, but you can have them. They're feel-good points. All right, thank you. Okay, awesome. Those errors, fantastic. Yeah, so computer tour, language history, white space, yeah, those sorts of things. Basic input and output. So dealing with, we didn't even really get to chapter 2 yet, but sure. So dealing with output is nice, right? We want things to show up on the screen. We never really, like the very last week, we get to the point where it actually like shows something interesting you can click on the screen. They call that graphical user interface. We need to start a little slower here, and everything is just going to be this text-based input here, this console input and output, because that's easy for us. The graphical stuff is a little trickier. So we're going to start basic. Next semester, we skip the graphical stuff too, and we keep doing more text input, because it's easy. Again, it's less things to worry about. So eventually you can do fun graphical stuff. We just don't get there yet. It takes a little while. All right. So to get input and output, right? Let's write a little program that does some arithmetic. Turns out Python can do arithmetic. I bet you're surprised. So let's see if we could like calculate someone's salary. So let's say, hey, if you make, and then how much do you want to make per hour? Shoot for the moon. Let's go big. $50 an hour? You will make, and then in Python, you can comma separate things to show up in your print. So when you comma separate them, they just keep on going. So I'll say 50 times 40. Now notice this isn't showing up in green because it's not in quotes. This is an expression or arithmetic. I'm telling Python, go calculate something for me in a week. So when I run this now, if you make $50 an hour, you make $2,000 in a week. Now I'm used to adding a bunch of spaces. So when you comma separate, Python adds a space between things for you. Other languages don't do that, so Python spoils us, and I'm usually adding spaces for things. So that's why there's like 2 spaces here. Xylabs would yell at me and say it's wrong because there's 2 spaces instead of 1. Yeah, question?
Yeah. So, how much do you break the string?
Yeah, so comma, then I can do something else that's not a string, and then a comma, I can do more strings. You can just have comma, like 2 strings as well if you want. It's silly to have the comma there, though. So, yeah, it's just a way to divide what we're outputting here with the commas. Yes, yep, we're going to get to that in just a minute. Yep. So we can do that. And then by week is nice, but a lot of people think by year, right? We'd like to know how much that is per year. So this is what, 101, 102K or so? Or 104, but probably 104K. So that would be, that makes, and then comma separate. So we want 50 times 40 times 52 per year. And then I like dollar signs, right? Do you like dollar signs? Because it makes your output look a little prettier. We don't really care. Python doesn't care, but it'll look a little prettier. Oh, they don't even line up now. That's fine. There's a gap there. That's fine. It's a little ugly. I'm not too particular right now. So yeah, 104,000 per year. Right? We multiply all that out. Now, what's boring though is every time I hit run, I get the exact same number. I'm pretty sure most of us in the room don't make $50 an hour. Right? It'd be nice if we could calculate it here for whatever our values were, what we had. And we should specify here, this is before tax. Right? Can't forget about taxes. The IRS will remind you otherwise, which is a whole other story. We'll get to that later, don't worry. I've got opinions. I'm sure you're not surprised. All right, so if we want to make this variable so that it can use different answers every time or different input every time, we use variables. So variable is a technical term for this is something my computer is going to remember when the program runs. It's going to hold on to it. So variables are just a place to store information. So I can say, hey, this is going to be my, now, there's a couple rules around how you name them. As long as you follow the rules, you can name it anything you want. So we could say this is dollars per hour, DPH. Please don't ever do that. That's a terrible variable name. Python doesn't care. It's happy with it. But if it's dollars per hour, put dollars per hour. Dollars. Now in Python, most people I know use the underscore character to separate their words. Dollars per hour. And we'll say this equals, or we're going to assign something to this variable. This is called snake casing, where you use underscores to separate your words. Other languages or other conventions use camel casing, where the first letter of each word is capitalized per hour, like the humps of a camel here. Generally, variables start with the lowercase letter. There's reasons for that. Don't worry about it right now. We'll get to it later. Generally, Python that I've seen is snake cased. Python could care less. Whatever your organization does when you go out to get a job, just go along with it. It doesn't really matter, right? But if we all follow the same convention, it's much easier for us to read the code, right? Because code's for people. So we're going to write code, we're going to read the code, and then our team will read our code, because hopefully you work on a team. It's really boring to work by yourself. And then when you move on to bigger and better things, someone else's job now will be to read your code and maintain it. Because it turns out it costs a lot of money to hire programmers to write code. So a company wants to make money. So they will spend money to have a program written, and they want to use that program for as long as possible. So what happens in the software development lifecycle, it's another fancy term you can learn all about, is that software is designed and built and maintained. Most of software's life is in maintenance, right? Just think of how long programs have been around before. Like, not everything is Microsoft Windows, but versions of Windows last for years and years and years and years and years. Versions of programs will last for years and years and years and years and years, right? Does anyone play Fortnite? It's still Fortnite. It's been maintained and like added to, but it's still Fortnite. It's been maintained for years and years and years because it makes them lots of money. Amazingly, people pay money for skins. Drives me nuts when my kids want to pay for the battle pass. But like, sure, use your allowance money. I don't care. They're like, I like the cool skins. Like, but okay, whatever. That's fine. They can make their money, and that's good. Fortnite makes money because if no one bought the skins, they wouldn't give the game away for free. So I guess that's a model. So software lives the longest time in maintenance, and when you go move on to bigger and better things, someone else's job will be to maintain your software that you wrote. If you gave it terrible variable names, they're going to hate you. And a lot of software engineers are just crazy people. And if they hate you, they're going to come find you and yell at you. We don't want that. You don't want to get yelled at by crazy people, right? That's no good. So we'll just name things nicely so our code is easy to read, right? Python doesn't care. The code is not for Python. It follows the rules of Python, so Python can execute it. But the code is written for people, so people can read it and understand it. Because you're going to write some code, and then an hour later, you might remember what it is. 6 hours later, you might have forgotten a little bit. A week later, you have no idea what you wrote last week. Because you've been busy 40 hours a week writing code. Who knows what you did last week? So you want to write your code so you can read it, and other people can read it too. All right, that whole long story to say dollars per hour. So dollars per hour, we're going to assign a value of, we'll say, input. And then with input, you need to set a parentheses. You can optionally give it a prompt. So you can say, in here, enter your hourly wage here, right? Great. So we'll take our dollars per hour now. This is a variable. Every time I run the program, it varies. The value of it varies based on what was entered. Yeah. Not in Python, no. Yeah, in other languages you do, but not Python. You're gonna be really bored then if you did Java already. I'm sorry. Okay. So what we can do now is I can use this variable name, dollars per hour, in place of a number. I don't need to have a hard-coded 50. I can say, let's do dollars per hour times 40. And let's do dollars per hour times 40 times 52, right? So it takes the place of a hard-coded number, and whatever the value is when it runs, Python will use that value. So if you entered 5, it'll use 5. If you entered 50, it'll use 50. If you entered 42.7, it'll use 42.7, right? Whatever value it is, it's just going to use that. So when we give this a run now, let's say, hey, let's do $10 an hour, right? Now we get, well, that's not right. So something happened here that's a little funny, and Python does funny things. Input has no way of knowing what you're going to be typing in. It doesn't know if it's a number, it doesn't know if it's a letter, doesn't know if it's a space, doesn't know if it's special characters. So everything input gives you is always known as text or a string. So we got the letters 1 and 0, not the numeric value 10. And Python lets you take a string and multiply it, which doesn't really make a lot of sense, but now I have 10 40 times. I have the characters 1, 0 repeated 40 times, and then the characters 1, 0 repeated a whole bunch of times. I don't even know what number that is off the top of my head. It's a big number. 2,000? Sure. Yeah, it's just sticking them together, repeating it 40 times. Yep. So if you want it to be a numeric input, we have to tell Python this is numeric input. When you're dealing with numbers, we have two choices. You have integers, which are whole numbers, means no decimal place, and you have floats, floating point numbers, numbers with decimal places. I don't know why they came up with the word float. Drives me crazy, but it's float. Sure. So if you want it to be an integer, we tell Python, I want it as an integer, as an int here. If you want it to be a floating point number, because a lot of people also make pennies, right? Not just dollars, so you want your pennies, we can use float. Now, fun fact, if an employer doesn't pay you the right amount and commits wage theft, it's very hard to prosecute and they get in very little trouble for not paying you the extra pennies that they owed you every time. If you steal the same amount of money from your employer, it's likely going to be a felony. Just a fun fact about American law, which is crazy. Take that as you will. So we're going to do floats here to make sure we pay you your pennies, because they add up. So I'm going to say, hey, take this input, turn it into a float for me so I can do arithmetic with it. Once it's a number, I can do arithmetic, and then 40 times that value will actually give me a number back, not the characters repeated over and over and over and over again. So let's try it again. So let's just say 10. 50 an hour. Well, we got to change this here too. So I need to change this one here. So I'm going to, again, just end my quote, comma, separate. Just add in the $sign here, right? Because we like $signs per hour, comma. Let's try that. 10. If you make 10 per hour, you will make 400 in a week. That makes 20,800 per year before taxes. Yay! Might sound like a lot, but that's not a lot. Sorry. That's a sad low number. So let's run it again. Let's try it again with our 50 example, right? 50 is fun. So if we make 50, that's $104,000 per year before taxes. Yay! All right, cool. So now every time I run my program, I can give it different input because I'm using variables. The value can vary. Right? That's what a variable is. It's the value can vary. That's all it is. And this equal sign is actually known as the assignment operator. It takes the thing on the right and assigns the value to the thing on the left. So when the program's running, things that are variables are stored in memory. So memory is our technical term. That's the RAM in our computer, the random access memory. RAM is really fast. Computers have generally gigs of memory nowadays, like 8 gig or 16 gig or 32 gig or whatever. That's how much information it can store in memory, which is very quick for it to access. The problem with memory is when you turn your computer off or lose power, it goes away. It's not storage. So storage, like your disk drive, your hard drive, or flash drives, or CDs, if people use CDs anymore, or something like that, is long-term storage. It will stay when the computer doesn't have power. So that's when we're going to write things to files so we can keep it around for later on, which most people want their data to stay around longer than when the program's turned on and the computer has power for a lot of things, right? Like it was really nice to have our schedule written down somewhere before classes started on Monday. Yeah, sure. Lots of things. So we'll deal with RAM or memory is our short-term storage. So anytime we declare variables, Python goes and asks your operating system, whether or not it's Windows or Mac or whatever it's running on, and says, hey, operating system, give me a place to store this, please. And your operating system says, okay, Python, here's where you go store it. It gives it a memory address. Doesn't mean a whole lot to us, but it's a location of where it can store it in memory. And when we go use that variable, when we say, hey, use this in the arithmetic, Python says, hey, operating system, give me the value at this memory address. And the operating system says, sure, here, it's a 40, or it's a 50, it's a 10, whatever it is. Then Python is able to use that in the arithmetic, in the calculations. So great. So we're going to store things in memory, and then we can use them later. And because our computers have gigabytes of memory, we can store lots and lots and lots of things. We're actually pretty lazy nowadays as developers, because way back when, computers used to have very limited amounts of memory, and people had to be very careful with the memory that they used. Sure, we don't really have to do that anymore. Eventually, in data science, we'll get to a very large scale where we're doing millions and billions of things, and memory matters. Because like holding a million values here is still actually really small. So in Python, a single integer is only 4 bytes. Byte is 8 bits, for what it's worth, so bits are zeros and ones. So the way things are stored, they're either on or off as a bit, and you put a bunch of bits together to represent some data. So everything in our computer is stored in zeros and ones. You put 8 of those bits together to make a byte, you put 4 of those bytes together to make 4 bytes, and you can store an integer. An integer can range between 2 billion some positive and 2 billion some negative. The reason why is it's a power of 2. So if we go to our calculator here, this is the fun fact. You'll need this, again, maybe later in your junior year. It's just a fun fact here. You can go to your programmer calculator here, and we can go to binary. So binary is the individual zeros and ones. So if I have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. This is 1. That's 1, 2. That's 3 bytes, right? 1, 1, 1, 1, 1, 1, 1, 1. That's 4 bytes, right? I have 32 individual bits all put together here. The value as a decimal number is 2 to the 8, 16, 24, 32, right? 2 to the 32. Is that right? 2 to the 31? It's not that important, right? So 4 billion some, but because integers can be positive or negative, we take away one of those bits and we say, I want to keep one of those bits to tell me if the number is positive or negative. Again, I don't remember which one is which. Either it's on and it's negative or it's on and it's positive. I don't care. It doesn't really matter. So we use 31 of the bits to represent the number, and we use 1 of the bits to tell us positive or negative. So we can store an integer. Now, thanks to the power of 2, right? If I add a couple more bits here, so you can have longer integers, right? And you can add a couple more bytes here. Every time you add a single bit, you double the size that you can store, right? Thanks to power of 2. It's a fun exponential thing, right? So if we add a bunch of bits, we can get to really big numbers really quick. Sure. That's very exciting. So everything's zeros and ones. So we group them all together. So if you have a million integers, you only have 4 million bytes worth of information. When you think about memory in your computer, you have bytes, you have kilobytes, you have megabytes, and you have gigabytes. A kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, or 1,000,000 bytes, and a gigabyte is 1,000 megabytes, or 1,000,000,000 bytes. So every gig of memory you have is essentially a billion bytes worth of storage. So 4 million integers, a million integers is only 4 megabytes worth of storage, and you have gigabytes worth of storage. So we get to be pretty lazy, right? So that's the whole moral of the story, why we went down that rabbit hole. We can store a lot of things at our basic level, and our computer could care less, right? Eventually, we'll do really, really, really big things. Not in this class, but in your training in school here, you'll do really big things that you have to be careful with. So we're just going to be lazy because it's easy. We don't really care, okay? And for floats, floating point numbers, they're even bigger here. It probably tells us in the book, but I can just Google it. Python size of float. Let's see. Size of a float. 64 bits. So a float takes up a lot more space, right, than an integer. And it was 32, so twice as much space to store a floating point number, but they're really big. You can store really, really large values. Here's our float.
Does it have any practical impacts on code?
I'm sorry?
Does it have any practical impacts?
So if you want to use floating point numbers and you have decimal places, you need floats. If you don't, no. So it's just behind the scenes how it's stored and calculations that computers do and stuff. Yeah. If you care about how calculations happen and that sorts of fun stuff that our friends who do electrical computer engineering or electrical engineering do, super fascinating. I just could care less. Like, I don't care how the processor figures out what times what is what. I just know that it does it and I can use it to make cool software. I'm really glad people know how it works because I like when people build computers for me. And if we didn't have those sorts of people, we couldn't build computers and cool processors and cool graphics cards and stuff like that. But I just don't care. So there's a lot of things I care about and a lot of things I don't care about. So you're going to hear a lot of biases from me. So just because I'm interested in it doesn't mean it's not cool. There's things I like. And sure. All right. Let's see. So I think we're pretty good there. English history, white space. Yeah, some calculators. Okay, we got a couple labs to work on. Awesome. I think we're in pretty good shape. Chapter 2, we started talking about variables, floating point numbers, arithmetic. We did some of that. Let's look at division and modulo. Modulo is a really fun word here. So when you're doing arithmetic, if you think back to 3rd grade math, you probably started doing long division, where you said, hey, this number divided by this number, you can find the result, or was it the quotient, and you can get a remainder, because we didn't figure out how to add decimal places yet. When I try and teach my daughter, hey, you just keep on dividing, just keep adding zeros, she got confused and like, where did the zeros come from? They're always there, we just don't write them, and that didn't make a lot of sense to her. Like, okay, I guess it's kind of abstract. Like, yeah, you get infinite zeros, and then you start talking about infinity, and you go down that rabbit hole, and my kid doesn't care anymore, which is fine, that's okay. So the remainder is very easy. Sometimes it's useful to know what the remainder is, and it's difficult for us to calculate a remainder without doing a whole bunch of work. Like if I said, what is, sorry, I lost it, 10 divided by 3 and the remainder? You just know what it is, right, because you do the math in your head, but like, how would you write that down? What are the steps you'd have to take? What do you do with 10? What do you do with 3? How do you get remainder 1? Well, like, you can subtract 3, and if it's bigger than 3, subtract 3 again. If it's bigger than 3, subtract 3 again. If it's less than 3, stop, and that's your remainder. That's kind of hard to put in code. We can, and we'll learn how to do that in 2 more weeks. We'll learn how to do that the hard way. The easy way is we use the modulus operator, or modulo operator. So let's just ask for some numbers. So we'll say, hey, first number is equal to an int. And let's deal with integers, because integers are easy, and we'll have good remainders here. Enter first number. And we'll have a second number is an int of enter second number. Oh, I missed a step here. Second number, an int of an input. There we go. Input. Not an input, input. And now I've got a red line here. It's saying a comma or a parentheses expected, right? I opened a parenthesis, but I didn't end it. Everything has to balance with our parentheses here. So int of an input and another parenthesis. Okay, cool. And then we can do some arithmetic. Let's print, how do we say, first number plus second number. Oops, we want in quotes here, right? Quote plus second number is equal to first number plus second number. Now this gets a little messy here, right? We're just saying, give me the value of the first number, like we did with our dollars per hour here. What's the value of it? Then we want to actually do arithmetic here in this spot. So sure, that should work. And then we'll do minus, and we'll do multiplied by, which is the star, right? Not the x, because x is a letter, right? I think by now we've gotten to the dot in math class. It's a weird switch for a while there. Let's do division. Division is the slash here. Here. All right, we'll see what we get. We'll get to remainder in a minute. So sure, hourly wage. All right, what's our first number? 10, and what's our second number? 13. So 10 plus 13, 23, 10 minus 13, 10 times 13, 10 divided by 13. Sure, here's an actual decimal answer. All right, well, what if we wanted the integer result and the remainder? We can do that. So we're going to copy paste here. Python, oh goodness, what did I do? Picked the wrong thing. So if you want to do integer division, you give it 2 slashes. Say, hey, give me the integer result. Right? But then we also want the remainder. total comma, remainder. Now, to get the remainder, we use the modulus operator. So this is first number, percent sign is the modulus operator, second number. It'll give us the remainder here. So we'll do 10 and 13, which is 0, remainder 10. Sure. So integer division, so let me add a comment here, right? So it's for integer division, and then is for modulus, or modulo, the integer remainder. Integer, there we go, the remainder. Okay? All the other arithmetic makes a lot of sense here, but this one's a little big, and I've gone kind of far to the side, sorry. Yeah.
So it's not a decimal.
Yep. So when you do arithmetic, it will give you a floating point result. Yep. So if you want the integer result, you specify. Because our fine folks at Python said, when you divide two numbers, you probably want the real answer, not an integer answer. Like the default should be what you want. In other languages, you get integer results by default, and you have to ask for decimal numbers, like when you do the division. Python is friendly, and will give us the real answer, which is the decimal place. Again, maybe that's not technically the real answer. It probably continues on beyond that. So like, it's close enough, right? 15 decimal places is plenty.
Is it almost
Is it the integer division modulus? Depending on what you're doing. It really depends on the arithmetic you need. So we'll come up with silly examples where we need to use them. Sure. Not all the time. So it's a tool that you have. So if you wanted to do this result, you do this. That's all. Cool. So that's our division and modulus. The math module is really cool. So a fun fact I learned about pi here. This is a really cool article. How many digits of pi do we need? There's a cool article written by the Jet Propulsion Lab at NASA. And we're all familiar with pi, right? You've taken enough math classes, we know what pi is. Let's see, Voyager, sure, whatever. How many digits of pi do we use? They use pi to, how many decimal places is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 decimal places for interstellar calculations, right? So Voyager 1 at 23 billion kilometers away, right? If they have a circle with the radius of 30 billion miles, or 48 billion kilometers, right? To calculate the circumference, using pi to 15 decimal places, you would come out to be, where's it here? Off by no more than the width of your little finger, with a circle of 148 billion kilometers radius. You'd be off by the distance of your Mickey with 15 decimal places. That blew my mind. Like, 15 decimal places doesn't seem like a lot for that big of a number, but sure, like that's pretty cool. I think at that point, their calculations are going to be off more because of gravity of things. I never took physics, which I was sad about, but I never needed it. But it sounds really interesting. But calculating gravity for interstellar missions sounds like it would suck. Because, like, everything is moving. I don't even know how they do that. Like, when everything moves and you have to figure out gravity. We got some really smart people out there, which is cool. Rocket science, probably really fun. Maybe? I don't know. Go talk to the Rocket Lab people. They might tell you about it. All right. That was a fun tangent. But pi, yeah, bunch of decimal places. All right, I think that's pretty good for today. We're going to finish up Chapter 2 when we come back next week on Wednesday. We'll finish out Chapter 2, and then we'll talk about our first project. Believe it or not, we're going to have our first project here coming up. So we'll use all the stuff from Chapter 2, and we'll do, again, just something, it's nothing fancy, but it's the project. It's your first chance to try these things. The general format, again, I think I mentioned, labs, ideally you're done by the time you walk out. An hour 45, you're done. Some people take longer, some people take less. If you finish it in half an hour, go home. Great. If it takes you 3 hours, you might not have done enough reading. Maybe that's the thing. Like, go do some more practice. Sort of use that as a measure. But I will help you finish the labs if you ask. I'm more than happy to do that because that's making sure that it makes sense to you, what you're doing, right? Okay. With the projects, I'll point you in the right direction, but I won't give you the answers. Like, hey, why don't you go look at this section, or you might want to try this technique, or you might have to do some division, like something, sure, right? And get you pointed in the right direction. Okay. Again, you're welcome to talk about labs, and welcome to talk about projects. Hey, I think I need to do this. English, right? Or any language, really, not other than Python. You're okay. So don't share code, but you can share ideas. That's great. Yeah.
Previous week's material, or is it from like what we learned on Monday?
So generally, we can get through most of the chapter on Monday. We might not be able to get through all of it, and the lab will be the stuff we've gotten through, which is most of it here. And then on Wednesday, generally, I'll go over the lab. Like, here's how I might solve the lab, which is useful, again, to see how I would solve a problem, which could be different than you. That's okay, because it's a creative process. Our steps are going to look different, but as long as we get to the same result, great. So I'll usually go over the lab and then finish up whatever we missed out of the chapter. It's my plan for the general flow. And then every other Wednesday, I'm also going over the solution to the project. So Wednesdays are going to be like going over labs, going over projects, and then whatever little bit we didn't finish yet from the chapters. So yeah, ideally we get through all of it Monday. It's a little weird to have lab in the middle, but we'll make do, and it works out pretty well. Yeah, other questions, thoughts, concerns? Happy first week of school.
What's the code?
I'm sorry?
What's the code?
Oh, the code, you go to the website, you plug in this, Dearborn, CIS 1501, Charneski Fall 2023. A real long thing, but like that's their unique, yeah. Yep, so that should bring it up. I think it's $89, sorry, but it is cheaper than the big textbooks. So, and I think it's worth it. It gives you some good practice. It's a pretty useful tool out there. It's got a lot of stuff. I like to imagine it's useful, so I don't feel so bad about making you pay money for it. That's all.
How probably right multiplier to efficient training? Will we assign these trainings or we just keep doing it?
You just here's the schedule. Just follow along. So there's nothing in Zybooks tells you to go do it by a certain deadline. No, we'll just do pretty much one chapter a week. Yeah. Awesome. Anything else? All right. Don't forget about Blue Carpet Day. Blue Carpet Welcome Day tomorrow. Free lunch. Right. Just go ahead and register. I don't know what lunch is, but hopefully it's something decent. The weather's supposed to be nice, right? And have some fun. It's sort of sad, but it is what it is. Again, the reality. Part of college is networking and getting to know people, and then you know those people when they get out in industry, and you know other alumni and those sorts of things, and you like build this network out. So it's not just learning things; it's also this other. That's part of why Ivy Leagues are so popular and fancy, because like you meet all the other rich kids who can go to Ivy League schools, who have rich parents who give them jobs, and they have this like sort of network, and they all hire each other because they went to Ivy League schools. They didn't learn anything different. I'm pretty sure. Like I've looked at their curriculum, so. What makes them better is they're a bunch of rich kids who went there and their daddies give them jobs and mommies give them jobs. So I'm a little biased, of course. I'm sorry. You're seeing my biases come out again. But all right, awesome. You folks take care. I will see you next Wednesday.